couple of minutes. Can you hear me? Yeah, so in the last lecture, last tutorial, we have done about the root finding methods, algorithms. In this tutorial, we will do matrices, right? So, have you got any reply, Shravan? The email you sent me regarding the assignment questions. Shravan is not here, I think. So I can start the tutorial.
Yeah, good afternoon. Sorry, actually, last time,
Yes, yes.
yeah, we got that. I think answers also. Uh, Probably only one question I had on doubt. That is fourth one: convergence of Newton's Raphson method when
Mm-hmm.
applied. Find a positive root to the equation
Mm-hmm.
x cube minus 3x plus 2.
Yeah.
Generally, like for NR, it is like 2, but it changes. Can we know like how to get that? Answer is 0. Sorry, I think answer is 1.
And you are talking about the assignment three? Or-
Yeah. Last week that is only clear. This week is fourth.
Okay, okay. So is the question not correct or you are not able to solve it?
No, just want to know how the one, how it is one.
How it is solved, right?
Yeah. Correct.
Well, I don't have any question of assignment three right now, but I can see the I have solutions. Maybe I can see. So do you have got the feedback form regarding the teaching quality or what? Have you filled that?
Yes, I have submitted.
How is it like? It's well, it's going well or
Yeah, it is good. Because that was helpful last time.
okay. Wait a second. Yes. Assignment three. Which question number you are saying?
It is number 4. Like, what is the convergence of NR method when we apply a positive, when we find the positive root of equation x cube minus 3x plus 2.
Okay. So the order of convergence is one, right? Because
Yeah.
the root is not, there are multiple roots of, if you see this equation, x cube minus 3x plus 2, then x minus 1 to the whole square is the factor of this equation, right? Of polynomial, sorry.
Okay.
So there are two roots. So you should note that if there is only one root of the equation, then we say that Newton method converges with second order convergence, right? And
Okay.
if there are multiple roots, then we will say that it converges with a first order
Okay.
convergence rate. So there the proof of this you can find out in the book that I've discussed
Wheat-
previously. It is
Wheatley.
Applied Numerical Analysis by Gerard Wheatley. Is
Wheatley.
it?
Yeah. I download. I think it is there in online.
Yeah. Okay.
Thank you.
Yeah. So we can move on with some problems.
Excuse me, sir.
Yes. Yes.
Sir, in same assignment number 3, question number 8 is also doubt. How uh, the option 1 is correct here?
In question number 8.
Yes, sir.
So wait, have your assignment three grading been
No,
done
sir.
or
No, sir. Excuse me, sir. Not question number 8, in question number 9.
in question number 9 you are saying?
Yes, sir.
So it's just finding the first derivative of this function, is it?
Sir,
What they are doing
because
here?
formula is xn plus 1 is equal xn plus fxn upon f dash
Okay.
xn.
Mm-hmm.
But after simplification, these outcomes not we get.
Means you are not getting the option required option, yes?
Yes, sir.
Okay, okay. You try that, I think it will be correct. Is it? Shravan, have you tried it? Question number 9. Is it wrong or there is some problem?
Yeah, I tried it. Actually, it was Newton's-Raphson method only. Only thing
Yeah.
with the bottom, one of the each options we have to, it is like xn minus f dash, f of x divided by f dash of
So
x.
you got the option, right?
No, there is one small problem. When we do
Okay,
that
okay.
f dash of x from the numerator to
Mm-hmm.
denominator, we will get extra number 2, like when we as a common, like it will be 1 by 2 will be common.
Okay, okay. So
Like
there is some problem. What is the option you are getting, both of you?
no, actually I gone with,
Closest.
yeah, I gone with
Closest.
the second only. Closest is second.
Mm-hmm.
Closest is
Closest
second.
is second, I think.
Yeah,
Mhm.
only thing it will have additional one more denominator numeral 2.
There may be some issue with the options, but the approach. Okay.
It is like simply like a numerator
So
you can.
Anil, you just take the closest option. What should I say now?
Sir, there is no close option because only the formula is xn plus 1 is equal xn plus fxn upon f dash xn.
Yeah.
But in option fxn and f dash xn is totally different from the given function fx is equal x e to power x minus 1.
Is it? Okay, I will raise this query enough. But in you just take option B then, if it is wrong. Okay. I will discuss this query with the tutor. I will mail.
Okay, sir. And sir, one more question is, uh,
Yes.
when we find order of convergence for any question, so this is same for all equation in general or a different, very for a different question?
It varies, right, for the different methods.
Sir, how we can find this? Because sir has told in
You just
lecture
read
only
the
the
book. You
procedure.
just yeah. Or for order of convergence, just read the book by Gerald and Wheatley.
Okay, sir.
Every method convergence is written there. It's easy to see. Just remember that.
Okay, sir. Okay. Thank you, sir.
Okay, now I can start. Can you see my screen?
Yeah,
Yes, sir.
yes.
Okay, let's start it. And folks, people are how many people are there? I just see it's 13. Okay. So yes, so we just stand up with the previous year assignment. Here it is. What happened? Is it because of? Wait a second. Anyway, okay. So let's start with the first question. So, okay, I will recall the methods that are useful. The first one is if one of the eigenvalues of A is 0, it implies, do you know the eigenvalues, eigenvectors of a matrix? In the lecture, I think you have seen it. So, first question, what does it say is that if one of the eigenvalues is 0, it implies the solution of system of equations is unique, determinant of A is 0, solution of system of equations is trivial, the determinant of A is non-zero. So what should be the right option if you learn about the eigenvalues clearly? What should be the right option?
Sir, I think option B is correct.
Why?
Sir, because sir has told if the determinant by determinant eigenvalues property, the determinant is product of eigenvalues, and here one eigenvalue is 0. So determinant is also 0.
Yes. And what about the first option? Why it is not true?
Sir, I don't know
So,
why it is not true.
okay. Let me write. Okay. So first AX is equal to B. This equation. Does it have a unique solution, right? Let me. Yeah, AX equal B. So if you have to, if someone asks you like, what is this equation have unique solution? Yes, if A is invertible. Okay. But if A is not invertible, then if A is not invertible, yeah, I'm writing this here. Then AX equal B system may not have. Can you give me an example of this? If I take A to be like, will it work or B is to be or 1 0 maybe. So if you take X is equal to X1, X2, what is AX equal B? X1 plus X2 is 1. So does it have a unique solution? A inverse exists or not?
No, sir.
What are the eigenvalues?
1 and 0.
Okay, right. 1 and 0. A inverse does not exist. Not unique solution. Okay. So it's just an easy one. Okay. And what about, okay, if you, okay, solution is system of equations is trivial. Is this correct? Is this correct? C option.
So what is the meaning of trivial here?
Trivial means only zero solution. Okay. So AX equals 0 is, so again, if A is invertible, then if A inverse exists, then X is 0, right? So trivial solution. But if A inverse does not exist, then you can't guarantee, right? Because in this example, if you take B to be 0, then what is the trivial, so what are the solutions? X1 equal. So any x1, x2 which satisfy this thing is a solution of this equation AX equals 0. So it's not trivial, right?
Sir Sharon, can you please explain that? Because actually, like the beginning also,
Yes.
it's the problem once again. Is also
Okay, okay, wait. You read the question, what you understand from it.
Yeah, if one of the eigenvalues is 0, like a n by n, that is,
Yes.
it implies what it implies. So the solution
Yes.
is B is unique.
Yes.
That is the first solution to Ax plus Ax equal to B. Then second is determinant of A is 0. Third is solution of Ax equal to 0. Systems of equations trivial. Determinant
Now,
of
which thing you don't get?
uh, pardon sir, I'm not getting
Which
clearly.
thing you don't understand in this question?
No, one is like now solution of Ax is unique means we are referring to, yeah, it is like um, we are referring it solution exists, like it is existing that
Yeah,
way.
yeah. Yes.
Okay, okay.
So you are saying about the existence of solution, is it?
No, no, sir. I'm actually just if the problem you are explaining one more with an example, that only.
Yeah, yeah. So you have problem in understanding this example,
Yeah,
maybe.
please. Yeah,
Okay,
can
then.
you explain? Yeah,
So you can see this, right?
yeah,
If A is invertible, then clearly It has a unique solution. X is equal to A inverse B.
Okay, correct.
But if A is not invertible, then can you say that it has a unique solution? We can't say that. So
We
for
cannot.
example, if A is this and
Okay,
B is this,
okay,
then and suppose X is the solution of the equation Ax equal B, where X is given by tuple x1, x2. Okay. Then
okay.
Ax is equal to B implies x1 plus x2 equal to 1. So how many x1 and x2 will satisfy this equation? Infinitely many, right?
Okay, okay, okay. Correct, correct. Yeah.
So not unique.
Mm, mm.
Similarly, if this happens, Ax equals 0, then A inverse exists, then X is 0. This is the only trivial solution. This is 0 solution. But if you take A to be 1, 1, 0, 0 again, then how many x1, x2 will satisfy this equation? X1 equal minus x2. Infinitely many. So there may not be unique solution. Is it fine, Shravan?
Okay, okay. Clear, clear, sir. Fine, clear. Yeah,
Okay.
thank you.
Which of the following step is not involved in Gauss elimination method? Do you all know Gauss elimination method? Should I recall it?
Yes, sir.
Okay.
Please recall one time.
Okay, let me go open the book. Just is it loading? Taking time, of course. Hmm, wait a second. Take some time. Maybe I can open another book. Do you have this book, MK Jan? Let me open. A second. Okay, let me go from another book. Wait. So these two books are good ones. One is MK Jan and another one is Gerard Whitley. This you just download both of these books. There is Gauss elimination method. Okay.
The name of the author, sir?
Uh, it's Gerard Whitley, but earlier the book I
Gita
was
Whitley
trying to
is
open
there.
is
Okay, okay.
it's
The other
MK Jan, but you try.
MK
MK
Jha.
Jan is good book for understanding matrices, but I not able to open that book, so I just switch it to waste.
Okay, no issue, no issue. MK Jain, what is the title? The same numerical methods.
Yeah.
Yeah, okay.
Okay, Gaussian elimination. What we do in Gaussian elimination, tell me. In this matrix, like how you do the computations, if you see this matrix, then you try to reduce it to upper triangular matrix. All right. That's it. By row operations. You know row operations?
Yes, sir. Yes, sir.
Do you know how this is happening? Like, I think from lectures. This is just easy, I think. Okay, so but there is one thing like, okay, so I think you have studied this that you can't divide by very small number. You have to change the rows, diagonal dominance and all.
Sir, can you explain once just?
After Gauss elimination, these things come like you can't divide by very small number because it leads to numerical errors.
Okay, sir. No, that's making converting to this lower diagonal. Can you explain? Like,
Yes, so you have to make the system, the matrix to be diagonally dominant for this. So
okay.
diagonally dominant
Yeah.
matrices.
What?
I think you
Yeah.
will see that.
Yeah.
Okay, so
Whatever.
this is just an easy one question. Wait. So what should be the answer of this question? Finding unknowns by back. Elimination of unknowns. Do we do that in this? First one is right. We do in Gauss elimination. Elimination of unknowns. Is it? We are trying to eliminate some extra coefficients, right? In every step. If you see this step here, so you're trying to eliminate, you are creating zeros in the first column, is it? So you're trying to eliminate x1 coefficients in the second row and third row. Okay. A second.
Yeah, clear. Whatever below the diagonal, we are trying to take it into zero, convert it into zero.
Yes. So you are trying to eliminate the unknowns.
Yeah, yeah, yeah.
You are trying to reduce to upper triangular system. Is it true? Right.
Yeah.
So
No,
this matrix is upper triangular. You know upper triangular matrices? Sure.
yeah, upper
Everything.
triangle. Yeah, upper triangular means below whatever diagonal, below whatever below the diagonal should be zero. No?
Yes.
Lower
And
triangle.
finding unknowns by back substitution. What is the meaning of this statement? Anyone?
That means we start to find the values from bottom to top.
Yes. So, okay. So can you explain in this how this is working, like back substitution? What is this
Yes,
in
sir.
this
Sir,
matrix?
so first we find the values of x3, then with the help of x3
Yes.
we find values
How
of
do you
x2.
find x3? How do you find x3? What should be the value of
Sir,
x3 here?
x3 is multiplied by 1.80 is equal 5.40.
Okay, so I can write here maybe. So you can find x3 from this 1.80 x3 is. And once you get x3, you can put it in this. Is it right?
Yes, sir.
Okay. And you find x2. Once you find x2, you put it in the first one. So it's back substitution, is it? Okay. And evaluation of cofactors. Are we doing this in this method? No, I can't see this. Are you doing this? Are you evaluating cofactors in Gauss
No,
elimination? No. So which
no, we
method
are
is
not doing
used
so.
to, in which method you evaluate cofactors? To find the inverse, right? To find the inverse of a matrix, you evaluate cofactors.
Yes, sir.
So how to solve the equation? Either you solve an equation ax equal b.
Excuse me, sir.
Yes.
Sir, in equation 2, option first, elimination of unknowns. What is the clear meaning of this option?
Wait a second. Yeah. Okay.
Sir,
Let
option
me
is
see.
elimination
Elimination
of
of,
unknowns. What is the meaning?
yeah, elimination of unknowns. Let's see. Elimination of coefficients should be clear, but elimination of unknowns. Yeah. So we are trying to eliminate unknowns. Unknowns elimination means you are trying to find the values step by step, eliminating each value. I think it should be the case, but it's a vague statement. Should write clearly.
Okay, sir. Okay.
This should be precisely written clearly. It's not, it's just a vague statement. Like Gauss elimination. Okay. So we try to find out using Gauss elimination method. Anyway, what I was writing, I forgot it. Okay, so how do you solve a system? Either you solve using x is equal to a inverse b, right? And so to find the inverse, you know how to find the inverse of a matrix. You need to find out the cofactors and calculate them. Another method is to use Gauss elimination to find this value. First method is the second Gauss elimination. Which one is more easier?
So
Which
second
one
one
is
is Gauss elimination.
Gauss elimination is much easier than this, right? Apply Gauss elimination method to solve the following equations. So we just try to find out. Okay, let's try to use Gauss elimination method now. Okay, let me copy this one. Just copy this. And the next page is good. Okay. Let's try to find out this feature. Yeah, so we have the system x1 minus x2 plus 2x3 minus x4 is minus 8. 2x1 minus 2x2 plus 3x3 20 x1. Okay. So what is the first step? To find the matrix, right? 1, 2, 1, 1. Just check it once. Am I doing right or wrong? -1, -2, 1, -1, 2, 3, 1, 4, -1, -3, 0, 3. Is it right? So it's A. Now what is the next step? Anyone? Which operation I should use? Okay, calculate the second row and tell me what the operation is. R2, R2 minus 2R1. Am I right?
Yes.
Yes, sir. Right.
Okay, tell me the what should be the second row? Okay, I leave second row for a while. Tell me after the operation, what is the values? This should be 0. Next one, 0. Next one. Is it right?
Yes, sir. Right.
Okay, which operation I should do next? Anyone?
R3 minus R1.
Yes. So R3. What are the values? Okay, it's 2 plus 8. Next operation.
Sir, R4 minus R1.
Yes. So it will be 1, 0, 0, 0, -1, 0, 2, -1, +1. Is it right?
Correct, sir.
Okay. What should be the next operation? Tell me. Are you able to do any operation now? What should be the next operation? Tell me, anyone?
Sir, I think R2 and R3 interchange first
Why? Why you think like that?
because in second row the element is 0 second element and we cannot proceed further.
Yes, yes, you are right. So what should we do? R2 interchange with R3, right? So 1, okay, 1 minus 1, 2 minus 1 minus 8. Only Anil is speaking. Anyone else? Okay, next operation, tell me. Tell me, anyone.
R4 replaced by R4 plus 2 R3.
Yes. Yes. Okay, sorry, I right. Is it right? Okay. So now, can you find the values now? Is it done or we have to do further more? Okay, tell me.
X4 is 2.
Yes, so what we have to do now? Back substitution. What is that? Yeah, x4 is 2. Yeah. What is x3? Tell me these values, x3, x2, x. Calculate and tell me.
X3 minus 6.
Yes, okay. X3 is minus 6, x2. What is x2 and what is x1?
X2 minus 1.
Yes, and x1. X1 is what? So are there options? Are we going correct or not? X1. Yeah, x1 we need to find out. X1. Calculate x1.
X1 1.
X1 is 1. Are you sure?
On scan. Let me cross check just. Okay.
3
12.
minus 7 or minus
Sir, why
6?
x3 is equal minus 6? I think x3 is must be 2.
Okay, that I have to solve, I think. You are not doing correct. Minus x3 minus x4 is minus 4. So minus
Okay. Okay.
x3
Sorry, I missed
minus
a
2
minus
is
there. Sorry, it's a mistake from my side.
x3 is 2, right?
Yeah, I missed a minus
Yes,
there.
Anil, you are right.
Yeah,
Yeah. And what about x2 now? 3 x2.
X2 is 1. Is it correct, Anil?
X2 is 1. Okay. I believe you. And what is X1? What is X1?
Wait, I am hurrying, otherwise I will miss that symbol also.
Why it's taking so much time? In exam, you have to practice, right?
X2 is equal 3, I think. X2 is.
X2 is 3. Yeah, that's what. It's an error. X2 is 3.
Correct. X2 is 3.
3.
And X1?
Sir, X1 is, I think, -7 from my side.
Okay. Yes, maybe this option is correct. Anyone else? -7 is right. Okay. So you know how to use Gauss elimination method, right? Let's go to another one. Yes, you can check this. Total number of multiplications are required in Gauss elimination and total number of divisions. Okay. There is some way to check it, is it? There is a thing where you can get it done. Operational count in this book. You can go with it and see what are the number of ways. I'm not going into this counting problem. Now we come to next method, which is LU factorization method. Okay.
Sir, please explain question number 4. What is the question 4?
Okay. Let me check. Yeah, it's just about counting the number of multiplication and divisions.
What is the meaning of this?
Yes, okay, I just explain you. So if this is the matrix, then how many times you are multiplying, right? How many times you are multiplying, doing multiplying, how many times you are doing division, right? So here you have done it one time, right? R2 minus 2R1. So 2R1, 2 times R1. So you have multiplied by 2, right? It's one time. And again, you have not multiplied it anywhere else. Yes, you have multiplied by here also 2 times. So it's 2 times you have done multiplication in this. But in general Gauss elimination method, it may not happen, right? So you have to count that.
Can we verify
Okay.
this question by that formula?
Let me see that. Okay, n cube by 3 minus n square minus n minus n by 3. So for n cross n matrix, right? Yeah, it's saying about the maximum number of multiplication and divisions. Okay, it's not saying about the exact. It's maximum.
In
Exact
case here we can
depends
take
on the
n is equal 4, sir.
matrix. Here n is 4, right? N is 4. Okay, let me just show you in this. So just a combinatorial. It's not here. So in general, in Gauss elimination method, what you do, you can see this one. You do AIK is equal to AIK minus AIJ into AIAJK. And you are dividing also by AJJ. So in every step, you are doing division and multiplication, right? This one and this one. Okay, wait a second. What is the first operation they have done in this? Yeah, so what they are doing in this, R2 minus 3 by 4 R1, R3 minus 1 by 4 R1. So here they are dividing by 4, right? And they are multiplying it also. You are dividing and multiplying in every row. Similarly here also. Okay, so here is that. But here the coefficient is 1, right? So you're dividing by 1. So it is, I am ignoring this, dividing by 1 and multiplying. So you are always dividing by 1 and multiplying by 2, dividing by 1. So this will count. In general, Gauss elimination operations will count this. So if I neglect this, then it will be less. If you include this, then it will be in general. You have to see this. If you have any problem, then you can just write it to me. But you will have to see it. It is, I think it is available in Amkijan book. The proof of this, you can see that. I don't know the correct answer to be sure of now. All
So
right.
so we have to check individually for all the options. Like, is it like that or general? This is
No,
general.
no, for in general.
In general, okay, okay, thanks.
Yes. You know in general, right? How to do Gaussian elimination of in general matrix.
Okay, okay, sir. Can you please just recall?
In general, how do we do Gaussian elimination? Is it
But whatever now we did now is for an example, the same way only, or
okay
you just recall it, it will be useful.
for general one?
Yes, sir. Yes,
Okay.
sir.
Let me wait a second. I plug my charger in. Yes. So in general, if you have a matrix like, should I take a 3 by 3 for easiness?
Yeah.
Have you not seen the lectures?
This one yet too, sir.
Anyway, okay. Okay, so this is a matrix, right? How do we do in general? Or maybe you can take B1. Tell me, what should I do in general operation? R2 should be what I have to subtract, right? R2 minus A21 by A11 R1. Is it right? So we are multiplying and dividing. So what is the answer? A11 0, A31, A12, A22 minus A21, A11, A12, A32, A13, A23 minus A21 by A11, A13. And similarly, you do, and I don't know this side, A3. And what is the next operation? Tell me yourself. Shravan, Anil, Sumit,
Sir,
anyone?
R3 minus A31 upon A11 R1.
R3
A,
minus,
A31
yeah, A31 by A11
upon
R1.
A11 R1. Yes.
Yes. So you can get it here to be 0. I'm not writing. Okay. And similarly here also some value. and here also some value. Then you just do this one. You just try to divide by this one and multiply by this one. Anyway, you can do this. Is it right? Can you do
Yeah,
in the
clear.
similar
Yeah,
way? Yeah.
clear, clear. Yeah.
Okay. Okay, let's go with you try to find out this answer, which is the principle of value factorization method. So value factorization, anyone knows value factorization? How to do it? Let's go with that.
No, sir has covered only Gauss elimination method only in previous lectures.
No, tell you?
No, sir. Only Gauss elimination method is covered.
Okay. And before that, the root finding algorithms. Okay, let me recall it once. Okay, so before which method it works, right? This method is Gauss elimination. We have covered it, so after done. So, what are ill-conditioned systems? Have you heard about it? Ill-conditioned systems. Like if you change the parameters, so if I go here, if you small, if you perturbate B1, B2, B3 by smaller amount, then how does the solution changes? If the solution is changing very vastly, then the system is ill-conditioned, right? So to avoid this ill-conditioned, as there exists some method, you can read that. We diagnose show that we have reduced solving inequality. Okay. Okay, so LU decomposition method is used to deal with ill-conditioned system anyway, any method is. So if you see this A, this matrix A, it is decomposed as L and U, where L is lower triangular and U is upper triangular. Upper triangular matrix has some general form, but L does not have any general form. L has a specific form where diagonal matrix, diagonal elements are kept at 1. Okay, so let's discuss this method and see what happens. Here I am. So there exists no inverse for a singular matrix. Determinant of identity matrix is 1. Every square matrix can be expressed as product of lower triangular matrix and upper triangular matrix. Every matrix can be expressed. So which one is true? In fifth question, I have explained you value decomposition, some layout. Which one is true in this fifth question?
Option C.
Yes. So you can decompose every square matrix as the product of lower triangular matrix and upper triangular matrix. So C is right. So
Sir,
apply
it is
LU
true
fact.
for every square matrix. There is no condition for the matrix is either it is singular or not singular.
Yeah, there should be a condition that I was thinking about. Okay, so I think the matrix should be non-singular if I am correct. I've heard this condition somewhere. Okay, so if the matrix is singular, then can you write it as LU decomposition because determinant of A will be determinant of L into determinant of U. So determinant of upper triangular matrix should be 0 in that case. Wait a second. Because here if you see this one, let me go. We can try on some example of a singular matrix and see whether it goes wrong. Here it is. Okay. Yes. Is it false? I'm going fast, I think. Yes, yes. So if you see this matrix A written as L into U, and determinant of LU is just determinant of L into determinant of U, and determinant of L is 1. So determinant of A should be same as determinant of U. So, and if determinant of A is 0, then determinant of U must be 0. I think it should work. If it determinant of U to be 0, it can work. You can decompose it. I feel so. You can try on a singular matrix and check whether it is working for it or not. Okay, let's try once maybe. Suppose we have a singular matrix 1 1 0 0. Okay, and LU 1 1 A 1 1. Okay, let's say it is B2 0 B1 1 B1 2. So what is B1 1? B1 2? Wait a second. It is just something. B1 1 and it is B1 2. And this is A2 1. Is it right? The multiplication? So now
Sir,
you
right.
check. B1 1 is 1. B1 2 is 1. A2 1. A2 1 is 0. A2 1 plus B2 2 is 0. A2 1 plus B2 2 is 0. So B2 2 is 0. Yeah, you can write every square matrix. You can write every square matrix as LU decomposition.
Okay, sir.
Is it correct? You can try with, you can check the proof of it, but yeah, you can try. You can write every square matrix. But it may not have like precise form of like the structure of a rectangular, and it may not have unique representation as LU. So in the case of invertible matrix, you do have unique LU decomposition, but in case of non-invertible, you may not have unique. Okay, so let's try this example. Apply LU factorization method for solving the equations 3, 2, 7. So like this I have done. Can you do this for question number 6? Should I solve it? 3x plus 2y plus 7z equal 4. Two x plus 3y plus z is 3x plus 4y plus. Okay, let me know how to solve it. So you have 3, 2, 3, 2, 3, 4. This is A, right? This is a new question. I think it's not. You just factorize. If you are given a solve a system of equations, you just try to factorize it. Factorize in LU. This is A and this is B is 4, 5, 7, right? And do you know if you factorize A as LU, then LUX is B. And this LZ is, what should I say? LZ is B, then you can Z if Z is UX. And you can find Z is equal to L inverse B. Once you have Z, then you can find X is equal to U inverse Z. Do you understand this step?
No,
Everyone?
sir. Please repeat again.
Okay, okay. So what is the use of LU decomposition to find the solution of a system? That I'm saying you. So if A is written as LU, then I replaced AX is equal to B by LUX is equal to B. Is it right? Then take UX is equal to Z. Then LZ is equal to B. Z is equal to L inverse B because L is invertible. Is it right? Then if you have Z, then you can go back to this equation to find out X. Now tell me. Yes. Anyone? So everyone has to understand this,
Yes, sir.
how to find X. So it's quite easy, right? If you have A to B singular matrix and you don't need to use Gaussian elimination in steps, you just use a decomposition to convert it into this way. Okay. So how do I proceed? How to find LU decomposition of A? I just take this. Oh my God. Yes. So I have 3, 2, 3. I will ask you from your side. What are the values of this? 3, 1, 1. Find out the values of and tell me. This is your work now. I'm waiting. Find out values of A1. Find out the values. These values A21, A31 from this equation. So everyone solve this and tell me what are the values of A21, B11, B12, B13 and so on. I'm waiting for 5 minutes.
Sir, I tell the matrix?
Yes, yes. What
The
is the
first one is 1 0 0
okay?
1 0
One.
0. Okay. 2 by 3.
Hmm.
Second row. 2 by 3 1 0. Third row 1 6 by 5
Hmm. And
1
what is U?
3 2 7 0 5 by 3 minus 11 by 3 1. Is it correct?
You are muted from your side. Probably we are not hearing you.
Sorry. Now you can hear me?
Yeah. Just we
Okay.
lost it. Yeah, probably. Yeah.
Yeah, what is the U value? Have you tried, Shravan?
Yes, sir.
This last
Yeah, doing it.
Sir, one is missing there. 0, 0, 1. U
one
upper
should be
triangle
there.
matrix.
Okay.
Yes, sir.
Okay. So what is Z3? Try to find out it. Z3 is Z1 plus 6 by 5. Now you can find out Z3 from here. Once you have Z1, Z2, Z3, you can just use Ux is equal to Z1, Z2, Z3. You have you have Z1, Z2, Z3, you find X. Is it easy? Using back substitution.
So can you go to that previous step? Just can you show that previous one?
Wait.
Like, yeah, L into U.
Yes.
Previously, just one. Yeah, here. So we got L,
What is the problem in this?
we got LU, and we have taken X. Okay. So lower triangular matrix into Z1 gives 4, 5, 7. 4, 5, 7. 4, 5, 7 it comes from, sir?
Hmm?
4, 5, 7
This is B, right?
going to B. Okay.
In this way.
Okay. The other one, right.
Tell me, is this clear? If there is any problem in any step, just let me know because I have to solve other questions as well. Is it clear?
Yeah.
Every step? Okay.
Yeah.
So in this one, you can try to find out this answer. What is the value, given the linear system, what is the value of alpha for which system has no solution? What is the meaning of this? So let's try this one. 2x1 minus it's 2x1 minus 6 alpha x2 3 and 3 alpha x1 minus x2. Okay. So would you like to use Gauss elimination method in this to find out the solution? So what is the procedure? So you will get it. Wait a second. So it's like 3 alpha. So or you just directly use it. Like you don't need to use. So you just try to find out the value of x1 from the first equation because I don't want to divide by alpha. So or you can use Gauss elimination anyway because we are using. So 2, 3 alpha minus 6 alpha minus 1. What is the operation? What should be the operation to make it 0? R2. R2 minus 3 alpha by 2, R1. Is it right? Minus 1. 6, 3 18 alpha square. Okay. Am I right? So this equation will have no solution if I think this happens, that 9 alpha square is 1. Alpha square is 1 by 9 and alpha is plus minus 1 by 3. Tell me, do you understand this one? Why it's no solution? Why I'm doing this? Tell me.
Is it no solution or is it infinite solutions?
No, it's no solution. Why it's infinite?
Like I can put any value of x1 and x2 and solve it. No, if it will be like both the
If alpha
equations
is
are
1
same.
by 3, if alpha is 1 by 3, then definitely it's infinite solution. Yeah, I should precise
Okay.
this. So if alpha is 1 by 3, then infinite solutions. If alpha is minus 1 by 3, then no solution. Tell me, why no in this case and why infinite in this case? And why I have put this equal to 0? Anil, anyone?
Infinite because the moment you put 1
Yes.
by 3 in the equation, both the equation becomes same, and you can practically have any value of x1, x2 and solve this.
Yeah. So if alpha is 1 by 3, then this is basically equal to 0. And this is equal to 0. So you can have any value of x1, x2, which can solve this first equation. Is it right, Mayuresh?
Yeah.
But if alpha is minus 1 by 3, then this becomes 0. This term becomes 0. And this becomes non-zero. So 0 can't be equal to a non-zero number,
Oh,
right?
okay.
Okay. So this is no solution. If someone asks you when is no solution, just put this coefficient, last one, which is what you have A33 to be 0. A22, A33, it to be 0. And this side should be non-zero. This one should be non-zero. This one should be 0. In that case, it should be no solution. But if both are 0, if alpha is 1 by 3, then this one is 0. So infinitely many solutions. Everyone, is it clear? Yes. There is any doubt, then you can ask. Okay. So like this, you can try to find out the number of multiplication division in LU factorization method, C book. I'm not going into much details of these. Which of the following matrices are diagonally dominant? Yes, tell me. What is the meaning of diagonally dominant matrix?
When the summation of
Yeah. If
the summation of all other terms other than diagonal is less than the diagonal term, then it will be diagonally dominant matrix.
what are you saying? Like A11?
For A11 should be greater than or equal to A12 plus
Yes.
A13, and likewise for the all the rows.
And what do you mean by strictly dominant matrix?
That equal sign will go out.
And what do you mean by what is the use of diagonal dominance?
What is that? Inverse.
Every diagonally dominant matrix is invertible. Are you sure? Yes, if you take any diagonally dominant matrix in the starting of any method, like Gauss-Jordan, Gauss-Seidel methods, you will always converge. That will always converge. All right. You can study this in M.K. Jain book. Yes. So which one is diagonally dominant in this case? It's easy, right? So now you
One
will
of the
tell me that, yeah, tell me.
The first one is diagonally dominant, but option doesn't looks like that. Okay, first one is
First,
diagonally dominant. A.
why it's diagonally dominant? You said like -6 is not greater than 5, right?
That's mod also is there. Mod.
Yes, you forgot that.
Yeah. Yeah.
Is it right now? Okay. So
Yes.
first
Yes.
one is diagonally dominant. Is it? Yes. And second
Yes.
one?
Yes. Second one is
Second one.
not,
Why?
because
Because it's
first is a
first row.
violation. 4
second
plus 3.
minus
4 plus
2
3
is
is
Yes. So next is Cholesky factorization of positive definite matrix. What do you mean by positive definite matrix? Have you heard it? To be layman, for in a layman language, for a 3 by 3 matrix to be positive definite, its eigenvalue should be strictly greater than 0. Okay. If eigenvalues of a matrix are strictly positive, then this is positive definite. Anyway, so you just need to find out the L and L transpose in this case. In what is Cholesky factorization? Let's go there. It's like
Yash, is it the only condition that eigenvalue should be positive?
yes, for a finite okay, for n by n matrix. Yeah.
Yeah, but there is no condition with respect to the determinant or something else.
Determinant, if eigenvalues are strictly positive, then what about the determinant? It will also be strictly positive.
That will become automatically positive. Yeah.
Yes.
Yeah.
Yeah. Determinant should be greater than 0. Wait a second. Is it LL? So Cholesky factorization is like this one. Okay, I can show you the steps. So here in this matrix, let's just try this one. Tell me, what is the okay. So where we were, yeah, this matrix, I just copy this one. Yes. What is L here? L is lower triangular matrix. So here we don't think, here we assume something like, wait a second, it's just, okay, it's just if I assume this one here, let me see once. Should I keep the L to be precise or on the diagonals? Yes, so here we don't need to do that. Here in general, you need to understand A11, A22, A3. And what is L transpose? So L transpose is just this A1100. Okay. Take the products A11 square, A11, A21. Okay. And A11, A13. Here A21, A11, A31, A11, A21, A11 plus A22 square, A31, A21 plus A32, A22. Like this similarly. A31, A33, which you can multiply this and let me know the values of where I am this matrix. This compare the both sides and let me know what is L. What is RL? That you need to find out. And that is Cholesky decomposition. And you try to find out the operational count of it by seeing that book again. Can you do that? Just try this. Find out the values. Yes. Have you done this? So I let you know the values. L is just 200 minus 0.520. Just try to check whether it's correct or not. Okay. Now, so I hope you understand all these questions. Yeah. Is this correct in this way? Yes, so it's like this. Yes.
Excuse me, sir.
Yes, yes.
Sir, why here we can why here we not take the value of a11 is -2? Because a11 square is 4, that means a11 is +2 and -2. So according to option, we take this or any other reason.
Yeah. You can take it -2 also. It will be a different one. We have to, yeah, you can take -2 as well. Hmm. All right, Anil?
Okay, sir. That means because
Yeah, it may
option
not
there
be
is.
unique.
Okay, sir.
Now, if anyone has any doubt, just ask it.
And sir, please tell me something more about positive definite. Either only one thing is that all eigenvalues are positive, then matrix is
Yeah,
positive
this
definite,
one
or
is.
any other way.
Any other way is to check about the norms, but you have noticed norms, right? Inner product. That is one thing dislike. If x is greater than 0. I don't know. You have studied inner product some amount for every x. But this is the easiest way to check it, that all matrices are positive definite too. Yeah, you can't say like if determinant is positive, then the matrix is positive definite. No. Only the ways to check using eigenvalues. And yeah, I know that eigenvalues calculation is not always easier. Yeah, but if you are given like if you have to use Cholesky factorization, then matrix should be positive definite. And the matrix that is given to you in the question is always positive definite if they say you to apply Cholesky factorization. All right. So you don't need to find out whether matrix is positive definite or not.
Yes, sure. Can I ask one question?
Yes.
Yeah, actually, you are referring one book. No, actually, I joined little late. I just wanted to know which is the book.
Okay,
MKGM,
let
right?
me know you the correct name of that book.
Yeah, yeah.
Wait a second, is it that book? Yeah, this is, you can see.
Okay.
Can you see this? Not this
Yes,
time.
yes. Got it. Yeah. And one more doubt. It is not in context of assignment, but with respect to the exam. Can I ask that?
Yes, let me stop sharing.
Yeah.
Yeah.
As it is scientific computing using MATLAB, no, will we be also having questions on the MATLAB, like programming kind of questions, program something on,
No,
it will not be there. So it will be all mathematics questions only.
will be basic MATLAB questions.
Oh, basic MATLAB, but it will be multiple choice questions.
Yes.
Okay. And the entire exam will be in MCQ mode only, right?
Yes.
Okay, thank you.
This is your
Like
first
there
time
are
in
certain,
NPTEL or
yeah, this is my first time in NPTEL.
okay.
Yeah. Because I heard and I have seen in the website that there are certain courses where you need to write the codes also.
No,
Yeah,
there are
so this
no
is
codes in
not the
this.
case right here. Okay, thank you.
Yes.
So yeah,
Only you can say you can learn from the lectures that you have seen in the initial week. basic MATLAB commands based questions will be there, and this is not so tough. Okay, so in the lecture, so in the class lecture, how much has been covered till Gauss elimination?
Till Gauss elimination, even though it is covered, but this assignment covers probably a next week half also.
Hmm. So have you seen those lectures? No.
No,
So
I have not seen.
I can
I
see the
don't know.
assignment maybe. Let me see the assignment questions. Solution, sorry. So assignment 3 has not been uploaded yet.
Assignment 3 is gone already, gone out of our hands.
So you have done. Sorry, assignment 4, I'm saying about it.
Assignment 4 due date is on 24th.
Wait a second. So Gauss Jordan method is also there in assignment 4, is it?
Yeah, there is a question on Gauss Jordan. There are questions on Cholesky and
So if you want to
decomposed.
study Gauss Jordan method, you just follow this book MK Jain, and in between, if you want to study, that would be good. So what I have been discussed today, these are all questions are almost based on that. So no special one, only one question on Gauss Jordan in assignment 4. So you can do any question. So out of 10 questions, you can get full marks in 9 questions, and one question is Gauss Jordan. You can try to learn it from MKN maybe. So I will do in the next tutorial.
Sir, also see the question number 4. In Cholesky method, only positive definite is needed or symmetric is also condition?
Yeah, symmetric also should be. You try to see the conditions of Cholesky method, but yeah, symmetric and positive definite.
Sir,
Yes.
sir, here we have solved one question of Cholesky method. Can you discuss where these conditions are used in Cholesky method, like symmetry and positive definite?
No, I think so. I can't. Here it's just I applied the method. It's just more of theoretical stuff, how people have done this. I'm not sure.
Okay, sir. Okay.
Just go through the book by MK Jain and let me know also, like why they have these conditions on this.
Okay, sir. No problem.
Any other doubt? But you try to practice it fast, right? You are doing slow every calculation. In exam, you won't get time. So assignment 5th is about next.
Do we have any question papers available from last years? Just to
Question papers.
just to get the feel of it.
I don't have that. You may ask calls. So you have course coordinator emails with you?
No.
No.
Okay, coordinator means the tutor, like the sir's
Yes.
mails, right? Okay,
Mhm.
we'll probably will ask them.
They will provide you. But the questions will be like that. That is based on assignments, right?
Yeah.
The questions will be similar to that. A little bit tough for open questions, but yeah, almost similar.
Excuse me, sir. Sir, please can
Yes.
you discuss one question for the order of convergence of assignment 3 if you have time?
Order of convergence. Okay, yeah, I can discuss that. Or wait. For any method you want?
No, sir, just 1 minute.
There is the applied mathematics, oh sorry, applied numerical analysis by Viral and Keatley. You can
Sir, in
find out
Newton-Raphson
the
method, sir has told
yes, yes.
if we want to find order of convergence, then we need 3 point error en plus 1 and en minus 1. And with the help of this, we can find order of convergence. But I am unable to how we can solve this.
What do you mean by order of convergence? First of all, this question. Tell me.
Sir, I think order of convergence means the rate that which the our approximation is goes to for exact route.
Yeah, so order of convergence is basically error at n plus 1 time step is dependent on error on previous time steps. Okay. So error at n plus 1 is just the multiplication is directly proportional to the square of the error in the previous time step in case of Newton's method. So it means that order of convergence is 2. If it's directly proportional to only en, then it will be order of convergence is 1, right? So the way we check the order of convergence is like that. All right. Like if you see in fixed point iteration method, maybe. Mm, yeah, so here you can see that error at n at time step is just directly proportional to the error at n minus 1 time step, not the square of that. So order of convergence is 1. So I can discuss. Should I discuss one proof of it? What you want, Anil?
Option method.
Oh,
Newton-Raphson method.
okay. So just see that in this, I just recall. So this is the definition of Newton-Raphson method. Can you see my cursor?
Yes, sir. Yes, sir.
Xn plus 1 is xn minus of xn bar dash. That's how we derive. And we
Yes, sir.
call this thing to be equal to gxn. And you just use, and this is like a which method? Fixed point iteration, is it?
Yes, sir.
So you can use the convergence criteria that if mod g dash x is less than 1, then this method converges. So mod g dash x is just calculate the derivative of g function and keep it less than 1. Then, okay. So what they are doing is, right. So r minus xn plus 1 is basically gr minus gxn. R is basically the root of this equation. So R satisfies R. R is basically, let me write, R is GR. R is the root of the equation, this equation, which satisfies this. So R minus xn plus 1 is GR. We can write R as GR and xn plus 1 as GXN. Then you just expand GXN using Taylor series expansion. Calculate mod G dash R to be 0 and ultimately you end up with this thing. Now using, yeah, En is just basically original root minus xn. That's called error, right? Error at nth time step. What is the error at nth time step? It's just the difference between the actual root and the approximation value at nth time step. So xn is the approximation, r is actual. So en is r minus xn. En plus 1 is r minus xn plus 1. R can be written as gr. Xn plus 1 can be written as gxn. And gr minus gxn is coming from Taylor series expansion. Is it all right?
Yes, sir.
So you can look at the proofs in the book and you will find out how it is coming. Yeah. Yes. So order of convergence has not been discussed in the lectures.
No, sir, it is discussed by sir, and sir has told me one formula for to find the order of convergence rate numerically, and that formula is phi is equal log en plus 1 upon en upon log en upon en minus 1. But I am
Okay, so
unable to
yes.
understand how we can use this formula for question.
Yeah, this question, this formula is not easy to use. So you can just follow these steps, proof of that.
Okay, sir.
So you are learning something or you are just not getting anything.
No, sir, I'm learning something, not something means बहुत कुछ काफी कुछ सीखने को मिल रहा है.
Okay, okay, just fine. Just the methods you need to apply them, and yeah, most importantly is how do you apply, which method you should apply in which situations. Critically, you should look in the book, like these two books, that they have provided the reasons in which case you should use these methods and in which case you should not use these method, and why this particular method is useful. And what if we remove these
Yes, can I
conditions
know
and so on?
the second book also? Can you tell which is the book? One
Okay,
you told MK Jain, another one.
wait a second. Okay, you can see this one. Can you see that?
Gerald. Yeah.
So numerical analysis is just has limited syllabus, not so much. The other subjects have much. You all are mathematics students or no?
I'm an aerospace engineering student.
Okay, everyone like Shravan was aerospace also. DRDO.
Actually, in last assignment, no, one more doubt. One doubt I'll
Yes,
ask.
yes,
Last
yes.
assignment,
Yeah.
question number 7. It was a quite simple question. That's by using second method, find the root of equation x minus k is equal to 1. Basically, order of convergence.
Hmm.
Yeah, and as it was x minus k is equal to 0, that means it's a straight line parallel to y-axis.
Great.
That yeah. And then when I was calculating order of convergence, no, I used the other. I just started with some random iterations and
Hmm.
uh, like found that in a second iteration we are getting the value.
Okay, so order
And
of
with that,
convergence.
when yeah, the question number 7.
Wait a second.
Is there any standard approach to this question, or do we need to go
Yeah,
with
yeah,
a
yeah, yeah.
couple of
So it's also
equations we
available
need
in
to
this
do
book. It's also available in this book.
in the Gerald, right? Gerald book.
Yes. So
Yeah,
convergence of
yeah,
second
but
method
just
and fast position.
yeah, just one like just to be particular on this problem, no, that was a x minus k is equal to 0, and just to find out the order of convergence, I did couple of two iterations. I just assumed some random guess x0 and x1, and on a
Hmm.
next very next iteration it could converge. But then with that, no, I have applied that p is equal to log formula.
Hmm.
So with that, I was getting order of convergence as 1, but finally answer was 1.618 as per the assignment assessment.
In
So
some example, you have tried it.
I have tried with like real example. X
Okay.
minus k is equal to 0. I have assumed x minus 5 is equal to 0. I assumed initial guess as 3 and 8. And with that, I started in the next iteration, it could
Why are
converge
you
to 5.
doing with the linear equation? Just try with the non-linear.
No. That was the question. No, x minus k is equal to 0.
Wait.
Question itself was that x minus k is equal to 0.
Okay. In question number
Yeah, but
7.
I know that when second method is applied, in general second method order of convergence is 1.62,
Mhm.
but that is the maximum order of convergence. But
Yeah,
for
yeah,
some
yeah.
equations it can be low, it can be in between also. So
Yes.
for this, when I just applied some real time numbers, I got order of
Mhm.
convergence as 1, and that is what I have written. But then finally the accepted answer is 1.618. So I
Also,
just
one was also
question is
there.
Yeah, one was there, and I also got one. But then I just wanted to know, is there any standard way of calculating this? How to go about
Yes,
this
yes. You
calculation?
just, yeah, these calculations are there in this book. I can show you. Here you can see
Yeah.
this convergence of second method and fast decision. You just try to look at this.
Yeah, this give, and this is covered by sir also in the lecture. It is covered by
Okay,
sir.
okay. Mhm.
It gives a proof that 1.62 will be the order of convergence.
Yeah,
But then if you look
these are
on after
95
some
show that.
examples,
So you may go through
yeah,
this
yeah, yeah.
citation
Then
link.
yeah, yeah. No, in fact, there is a detailed proof given in the lecture, in the video
Okay,
lecture.
okay. Yeah.
But my question is not that. My question is, this is the maximum number which can be achieved by using second method. But for
Yeah.
any particular problem, my question is, whether is there any standard operating procedure how to find out the order of convergence?
For any particular problem, you are saying it,
And
and
for
not
any
in
particular
general.
problem, like the given problem, no, x minus k is equal to 0.
Yeah, 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 yeah. Mhm.
You
So you
got
are
my
not talking in
question, sir?
general. In general,
I'm not talking in general. In general, they have given the numbers 1.2 for Newton Raphson,
yeah, yeah.
1.62 for second,
Just a
and
standard
regular
numbers.
Paulson.
Yeah.
Yeah, these are standard numbers, but for,
Mhm.
and it is also written
So
at
in
a couple of
general, you can
places.
try this. You just try to yeah. So you just try to calculate en plus one and en and calculate the ratio between en and plus one and en.
Yeah, and then
The
log of that
absolute
by
values.
using the formula.
Yeah,
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 that's what I did. Okay, but don't know where I have done mistake.
yeah. Okay. But if say asked in exams, then just take this 1.618. Don't go with particular one. Please say they take them as standard.
Okay.
I think I should stop now.